Let's review some rather easy questions from an earlier module. Do you remember these fundamental rules for dealing with exponents in algebra? If you had any trouble completing these statements, you should review the module in exponents before going ahead with this one. But if you're comfortable with exponents, let's warm up by simplifying this expression just to dust off your skills putting these rules to work. Pause the program, and when you have an answer, hit play again, and we'll compare our solutions. The order of operations is important here. Let's get rid of those brackets or parentheses first by applying the third rule. That is, by multiplying exponents. Then we'll use the division rule, first on x and then on y. Subtract the exponents, top minus bottom, which gives us the answer. Did you get it? Good. Now let's consider another idea, one that goes all the way back to arithmetic. The normal way to do this problem is to start with the addition inside the parentheses and then multiply to get 14. But there's another way, another right way. We can leave the 3 and the 4 in the parentheses separate, multiply each of them by 2 separately, and only then add them together to get our correct answer, 14. But why do it that way? Why not add the contents of the parentheses together right away and be done with it? With numbers, that's easy to do, but sometimes we have letters inside the parentheses, and we can't add them together when they're not like terms, when they are unlike terms. Numbers or letters, we apply what's called the distributive law. We distribute or spread what's outside the brackets over all the terms inside the brackets. Here's what it looks like in algebra. And notice again why we really need this idea. Inside the brackets or parentheses, we can't do any addition or subtraction because B and C are unlike terms. With all that in mind, try to simplify this expression. Here's a hint. We've seen the rules for exponents and the distributive law. In this problem, you'll want to combine the two, using the rule for multiplying terms with exponents. Pause the program while you work out your answer. When you've got it, hit play again, and we'll compare our solutions. Ready? The two expressions inside the parentheses are unlike terms. We can't add them, so we have to treat them separately. That's our distributive law in action. So we multiply each expression separately by the x squared y cubed, which is outside the parentheses. That gives us two multiplication problems with a plus sign in between. Let's do them separately. Expression 1, we use the multiplication rule, so we add exponents. Expression 2, same thing. X's first, then y's. And the z doesn't change. We put the two parts back together for an answer, the combination of these two unlike expressions which cannot be further simplified. Think you got it? How about this? We add another term. What do you suppose happens when we find inside the brackets not two terms, but three? We apply the same distributive rule. We create three multiplication problems, namely x squared times each of the three terms inside the brackets, which you simplify in just the way you would expect in all three cases. This will not be the last time we see important consequences of the distributive law. Now let's look at a multiplication problem that's a little more complicated. It has two sets of brackets multiplied. Instead of the single term, we now have brackets containing x plus 2. How will we handle that? By thinking simple. Remember how easy it was to think about a times b plus c? Think about the whole first set of brackets in the same way, as a single unit like the a. Here we'll just turn it into rex for the time being. What do we do with that? Just apply the distributive law and multiply rex times each part of the second expression. That becomes rex times 3x minus rex times 4. Now let's replace rex with what rex stood for in the first place, x plus 2. And it starts to look like something we have seen before. We have two terms with a minus sign in between. What if we change the appearance of each to a more familiar form? Each term has two things multiplied together. Remember the commutative law? It's the one that says 2 times 3 is the same as 3 times 2. So it's okay to reverse the order. Now that the problem looks like this, can you see what to do? Of course. We just apply our distributive law again, twice. Be careful about that last negative sign. Remember that you are multiplying by -4. Right away, we notice the like terms, 6x and -4x, and combine them to get our final answer. That was a workout. We used our distributive law 3 times to multiply out the two sets of brackets, but it worked. Here's a secret. There's a much easier way to do exactly the same thing. It's called the FOIL method, F-O-I-L. We'll use it on the same kind of problem we just saw, the kind with two sets of brackets. FOIL tells you what to multiply. F first. Multiply together the first terms in each of the two sets of brackets. A times C gives us AC. O, outside. Multiply together the two outside terms, the far left and the far right. A times D gives us AD. We add that onto our answer. I, inside. Multiply the two inside terms, B and C, and add BC to the answer. L, last. Multiply the two last terms, B and D, and complete the answer with BD. The process of multiplying two terms by two terms is called multiplying binomials. Usually, you can carry out most of the steps in your head. The FOIL method allows a picture like this. What would happen if we went back and used the FOIL method on that problem we did the long way with the distributive law? Let's find out. First, x times 3 gives us 3x squared. Outside, x times -4 gives us -4x. Inside, 2 times 3x is 6x. Last, 2 times -4 gives us -8. We combine the like terms and come up with exactly the same answer as last time, but we got there a lot faster this way. Notice that problems which multiply two terms by two terms gives us 4 terms in the answer before we start combining the like terms. That same pattern applies to a problem like this one, 2 terms times 3 terms. We should see 6 terms in the answer before we combine like terms. That's because we multiply everything in the second expression by everything in the first expression, just as we did when we used FOIL. Try this one by yourself. Think about it this way. Multiply everything in pairs, just the way we did with FOIL, F-O-I-L. Then combine like terms and you'll have an answer. Pause the program. When you have your answer, click play again and we will work through it together. Did you use steps something like these? I started with the first term, multiplying 2x by every term in the second brackets. Use the exponent rules and watch the signs carefully. That gives me half the answer, 3 terms. Then I repeat the process with a -y and get the rest of the answer. So the problem and the full 6-term answer looks like this before we simplify by looking for the like terms. Did you find 2? And then we combine them to get the final answer. Incidentally, can we call this answer a binomial? No, because it has more than 2 terms. It's called a polynomial expression. A binomial is an expression with 2 terms. This kind of multiplication is basic in algebra. You'll want to be sure that you really understand how it works. If you don't quite have it, check out what your textbook has to say about multiplying binomials. While you're there, do more problems right away. I can guarantee that later on you'll be glad you did. You see, we will come back to this multiplication process again, but at that time, we'll do it backwards. So, can you do these 3 problems and understand them? Before you go on to factoring, knowing the answers well will be a huge help. Here are the answers. Remember, you'll see them again and you'll need them when we take up factoring. Before we go, I want to make sure you see the pattern here, because it's all been much simpler than it may have appeared. We've really been doing the same thing in every example. Applying the distributive law to a simple problem like 2 times 3 plus 4 looks very much like applying the same law to 2 times x plus y, and it is, with exactly the same kind of result. When we substitute a times b plus c, same thing again. xy times x plus z may appear more complicated, but look, it's exactly the same pattern. And if we have 3 terms inside the brackets instead of 2, it doesn't change a thing. It just adds one more term to be multiplied. And when we get to multiplying binomials, 2 terms times 2 terms, we still have exactly the same thing, except that we have it twice in the same problem. The first term, a times everything in the second brackets. And then the second term, b times everything in the second brackets. If we use our arrows to show the same thing, you'll notice it's actually the same thing as FOIL, F-O-I-L. The first, the outside, the inside, and the last are all multiplied. Are you starting to see the pattern here? Even if we had a longer problem, we could do it the same way, without changing our pattern at all. How about this problem? 3 terms times 3 terms. What do we do? Exactly the same pattern we've used in every other case. Multiply the first term in the first brackets times every term in the second brackets. And the second term times every term in the second brackets. And the third term times everything in the second brackets. Then combine the 9 terms from all 3 steps for a final answer. In this case, there are no like terms to combine, so the pattern stays very clear. Usually, you will see some like terms to combine to simplify your answer. But the important thing to notice is that we've used the same pattern in every case, simple or complicated, and it works as well on big problems as small problems. Keep the pattern in mind as you practice other problems. Remember, no matter how complicated the problem looks, the pattern is always the same. Practice on more problems right away while these ideas are still fresh, and you will be able to handle multiplying binomials wherever you meet them.